Welcome to the lesson on basic constructions. At the end of this lesson, you will be able to construct a bisector of a given angle, a perpendicular bisector of a given line segment, and an angle of 60 degrees at the initial point of a given ray. The construction of an angle bisector, a perpendicular bisector, and an angle of 60 degrees are the three basic constructions that will be covered in this lesson. After constructing these figures, we will verify the results logically. Let's begin with the construction of an angle bisector. An angle bisector is a line that cuts an angle into two equal halves. Here's an angle. Let's name it DEF. ED and EF are two rays. To draw a bisector of this angle, we'll need a ruler and a compass. On the compass, take an arc of a small radius. Taking E as the center, draw an arc on rays ED and EF. The arc intersects ray ED at G and ray EF at H. Now with the same measure, place the compass on point G and draw another arc. This arc will lie within the angle DEF. Repeat this step by placing the compass on point H. The arc that is drawn intersects the previous arc. Name the point of intersection as I. Now, let's draw a ray from point E passing through the point I. This ray, EI, is the bisector of angle DEF. Let's verify this statement. On measuring angle DEF, we find that it is 80 degrees. So the two angles, DEI and FEI, formed by the ray EI should measure 40 degrees. Let's check this. Yes, each angle is 40 degrees. Hence, ray EI is indeed a bisector of angle DEF. We have successfully drawn and verified the construction. Now let's prove this construction logically. In order to prove our construction, we'll have to prove that angle GEI is equal to angle HEI. To begin with, let's join points G and I and points H and I. Now, two triangles GEI and HEI are obtained. Let's derive some facts about both the triangles. If you recall, points G and H were obtained by drawing a common arc. So EG and EH are along the radii of the same arc. Hence EG is equal to EH. Similarly, GI and HI are equal, as these two are also radii of the same arc. EI is common to both triangles GEI and HEI. By the SSS rule, triangle GEI is congruent to triangle HEI. When two triangles are congruent, the corresponding parts of the congruent triangles are congruent. Therefore, angle GEI is equal to angle HEI. The ray EI divides the angle DEF into two equal halves. Hence, it is proved that ray EI is a bisector of angle DEF. Next, let's construct a perpendicular bisector of a given line segment. A line segment LM of length 10 cm is given. Let's mark the midpoint of the line segment LM as O. Draw a line passing through the point O. This line is the bisector of the line segment LM. A line bisector is a line that cuts a line segment into two equal halves. Now, let's align this line such that it is at right angles with the line segment LM. The line is now a perpendicular bisector. By definition, a perpendicular bisector is a line that divides a line segment into two equal halves and forms a right angle with it. Now, let's construct a perpendicular bisector using a scale and a compass. Here, another line segment PQ is given. We do not know its length. Taking point P as the center, mark arcs of any radius on both sides of the line segment PQ. Similarly, taking Q as the center, with the same radius, draw arcs on both sides of the line segment PQ. These arcs intersect the two arcs drawn from point P. 2 points are obtained from the intersection of these arcs. Name these points R and S. Draw a line passing through points R and S. This line intersects the line segment PQ at M. Is the line RS perpendicular to the line segment PQ? Let's measure the angle formed at the point M. The measure of the angle is 90 degrees. The line RS is perpendicular to the line segment PQ. It also divides the line segment PQ into two equal halves and also forms a right angle at point M. The line RS is indeed a perpendicular bisector of the line segment PQ. An important point to note is that you cannot draw a perpendicular bisector if the radius of the arc is less than half the length of the line segment. Now, it's time to verify this construction. That is, we will prove that the line RS is perpendicular to the line segment PQ and also bisects it into two equal halves. In order to prove this, we have to prove two conditions: the condition of bisection and the condition of perpendicularity. First, we will prove that the line RS bisects the line segment PQ. As you can see, they intersect each other at point M. Now, let's join the points P, Q, R, and S. Now, let's join PR, PS, and QR, QS. Two triangles RPS and RQS are formed. In these triangles, PR is equal to RQ and PS is equal to QS. As both are the radii of the same arc, RS is the common side. Therefore, by SSS rule, the triangles RPS and RQS are congruent. By the CPCT rule, angle PRS is equal to angle QRS. Now, let's consider the other pair of triangles. Triangle RMP and triangle RMQ. Here, side PR is equal to side QR, as these are the radii of the same arc. RM is the common side. As proved above, angle PRM is equal to angle QRM. Therefore, by SAS congruence rule, the triangles RMP and RMQ are congruent. By the CPCT principle, side PM is equal to side QM. This proves the condition of bisection. Similarly, by CPCT, angle RMP is equal to angle RMQ. The angles RMP and RMQ also form a linear pair. Since angle RMP is equal to angle RMQ, we can replace angle RMQ in the equation. Since both angles are equal, their measures are 90 degrees. This proves the condition of perpendicularity. Therefore, it is proved that the line RS is a perpendicular bisector of the line segment PQ. We have completed two constructions. Now, let's take up the third. Here, we have to construct an angle of 60 degrees at the initial point of a given ray. A ray PQ is given. We will construct another ray PR originating from point P, such that it makes an angle of 60 degrees at P. Draw a big arc, taking P as a center. The arc intersects the ray PQ at point C. Next, with the same radius and taking C as the center, draw another arc. Name the intersection of the arcs as point D. Now, draw a ray PR passing through D. What is the measure of angle RPQ? Let's measure it using a protractor. The angle constructed measures 60 degrees. Please note, even if we take an arc of any other radius, the angle made between the two rays will always be 60 degrees. From the triangle, you can observe that PC is equal to CD is equal to PD. Thus, triangle PCD is an equilateral triangle. Therefore, the constructed line PR makes an angle of 60 degrees with line PQ. Welcome to the lesson on constructions of triangles. At the end of this lesson, you will be able to construct triangles given its base, a base angle, and the sum of the other two sides. Its base, a base angle, and the difference of the other two sides. Its perimeter and its two base angles. The construction of an angle bisector, a perpendicular bisector, and angles are some of the basic constructions used for constructing geometrical figures. With the help of these, we'll learn to construct some triangles. Let's start with the first construction. Here, we'll construct a triangle where the base, one base angle, and the sum of the other two sides are given. Let's construct triangle PQR, where the base QR is equal to 5 centimeters. Angle PQR is equal to 60 degrees, and the sum of its sides, PQ and PR, is equal to 8 centimeters. Here's how it's done. First, draw a line segment QR of length 5 centimeters. Draw a ray QX inclined to the base QR equal to the given angle PQR, which is equal to 60 degrees. Take the measure of 8 centimeters and mark an arc S on the ray QX. This is the combined length of the sides PQ and PR. Join RS. Draw the perpendicular bisector of RS such that it intersects QS at P. Finally, we join PR. Thus, PQR is the required triangle. Now, let's verify if the triangle obtained is the required triangle. In the figure, side PR is equal to side PS. Since any point on the perpendicular bisector is equidistant from the end points of the line segment. Now, PQ is equal to QS minus PS. This implies PQ is equal to QS minus PR, or PQ plus PR is equal to QS. Thus, in triangle PQR, QR is equal to 5 centimeters. Angle PQR is equal to 60 degrees, and the sum of the sides PQ and PR is equal to 8 centimeters. Hence, verified. Let's now proceed on to the second construction. Here, we have to construct a triangle when the base, one base angle, and the difference of the other two sides is given. Suppose in triangle ABC, we are given the base BC, base angle B, and the difference of the other two sides AB and AC. Please note that there will be two cases of constructions. In the first case, AB may be greater than AC, and in the second case, AB may be shorter than AC. Let's construct the triangle when AB is greater than AC using the given data. To begin with, draw the base BC with a length of 5.5 centimeters. At point B, make an angle XBC equal to 40 degrees. Taking point B as the center, cut an arc with a radius of 2 centimeters on ray BX at point D. BD is equal to the difference of the given sides. Join DC. Draw a perpendicular bisector of the line segment CD such that it intersects the ray BX at point A. Join points A and C. Thus, ABC is the required triangle. We shall now verify whether the triangle we have drawn is the required triangle or not. AD is equal to AC, since point A lies on the perpendicular bisector of CD. Therefore, BD is equal to AB minus AC. the constructed triangle ABC is the required triangle. Let's now construct a triangle of the second case with the given data. Here in triangle ABC, side AB is less than AC. The first step is exactly the same as it was in the first case. Draw the base BC with a length of 5.5 centimeters. At point B, make an angle XBC equal to 40 degrees. Extend ray BX in the opposite direction. Mark an arc with a radius of 2 centimeters on the extended ray BX at a point D. BD is equal to the difference of the given sides. Join DC. Draw a perpendicular bisector of the line segment CD such that it intersects the ray BX at point A. Join the points A and C. Thus ABC is the required triangle. Now let's verify it. In this case, AD is equal to AC since point A lies on the perpendicular bisector of CD. This implies BD is equal to AC minus AB. Thus the constructed triangle ABC is the required triangle. Lastly, we are going to construct a triangle where its perimeter and two base angles are given. Let ABC be the given triangle in which the sum of its three sides is equal to 15 centimeters and the measure of its two base angles B and C are 70 degrees and 40 degrees respectively. Let's start with the construction. First, draw a line segment XY of 15 centimeters, which is equal to the perimeter of the triangle. Draw a ray XL at point X, making an angle of 70 degrees with XY. Similarly, draw a ray YM from point Y, making an angle of 40 degrees with XY. Now, draw the angle bisector of angle LXY. Similarly, we'll draw the angle bisector of angle MYX at angle Y such that it meets the angle bisector of the angle LXY at point A. Next, we'll draw the perpendicular bisector of AX such that it meets XY at point B. Similarly, we'll draw the perpendicular bisector of AY such that it meets XY at point C. Finally, we'll join AB and AC. Thus, triangle ABC is the required triangle. Now we shall verify whether the triangle obtained is the required one or not. B lies on the perpendicular bisector of AX. This implies XB is equal to AB. Also, C lies on the perpendicular bisector of AY. This implies YC is equal to AC. Now, the perimeter of the triangle ABC is equal to the sum of its sides. But from equations 1 and 2, we can see that the sum of the three sides of triangle ABC is equal to XY. Now, we'll show that angle B is equal to 70 degrees and angle C is equal to 40 degrees. Since angles opposite to equal sides of triangle are equal, this implies angle AXB is equal to angle XAB because side XB is equal to side AB. Now, in triangle AXB, exterior angle ABC is equal to the sum of two interior opposite angles AXB and XAB. From equation 3, this is equal to twice angle AXB, which is equal to angle LXY. Thus, angle ABC is equal to angle LXY, which is equal to 70 degrees. Similarly, we have angle ACB is equal to angle MYX. Therefore, the triangle ABC is the required triangle.